All right, so here's your study guide for quiz 9. And before we get going here, I need you to add a note right here. And it's going to say that if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. So when we're looking at this first diagram, if I label this center A, and this segment that's 8 units long that's perpendicular to chord BC, if I were to extend that vertically to point D, all right, wouldn't AD be a radius? And now we've got a radius that's perpendicular to a chord. So when that happens, it bisects the chord and the arc. So if the left portion of chord BC is 6, then the right portion is 6. Now we're looking for X. X is the radius. Well, all we're going to do is we're going to draw in this radius from A to C. And we're just going to move the X to here. And now we have a right triangle. And in that right triangle, we can use the Pythagorean theorem to find this radius. So 8 squared plus 6 squared equals X squared. And 8 squared plus 6 squared is 100. And if we find the square root of both sides, then 10 is equal to X. Everybody okay with that? All right, same concept kind of here on number 2. Now, though, if I label this C and I label D.
Interruption. Can you please send the following students to 12103? I need Arlen. I need.
This dimension that you're given is the entire chord. All right, again, we've got a radius perpendicular to a chord, so it bisects this chord. We need this X piece, which is the radius. So if I label this A again, A to D is also the same as X. And this piece is going to be 23 divided by 2. Which is 11.5. So to find this radius, we're going to take 7 squared plus 11.5 squared equals X squared. $181.25 is equal to X squared, and then we're going to find the square root of each side. So 13.46 is equal to X. All right, in problem number 3, use diagram. Use the diagram. AB is the diameter. So AB is the diameter. AB is perpendicular to CD. So you've got a diameter perpendicular to a chord. That means CP is congruent to PD, and arc AC is congruent to arc AD. Find the measure of arc BD, which is right here, for the measure of arc AC is 59. So if A to C is 59, and we need arc BD, well, if A to C is 59, then A to D is 59. And since AB is a diameter, then arc AB is 180. So arc CB would be 180 minus 59. All right. So this arc is 121 degrees. Which leaves this arc at 121 degrees. All right, everybody see why these two arcs would be congruent? On the top half, we have a semicircle with one angle that's 59, or one arc 59, the other one's 121. On the bottom, we have a semicircle, one arc that's 59, the other arc has to be 121. All right, in problem number 4, WZ and XR are diameters. So W to Z, it's a diameter. X to R is also a diameter. So find the measure of arc ZWX. All right, ZWX. So we're going from Z through W, and we're ending at X. Well, from Z to W is a semicircle, so that portion's 180. And from W to X, that arc is equal to its central angle, and its central angle is 46. So Z through W ending at X is going to be 180 plus 46. $226. And I encourage you tomorrow when you take the quiz to make sure you've got some good clean scrap paper and that you've got a couple different colored pencils. It'll make doing these problems much easier if you can draw them on your paper and then highlight exactly what you're looking for. Number 5, the radius of circle O is 18. The radius O to B is a radius, that's 18. OC is 13. That's right here. Find AB. We need this whole chord. All right. AB is going to be equal to 2 times CB, because we've got a radius perpendicular to a chord, so the radius bisects the chord. So we're going to use the Pythagorean theorem again. CB squared plus 13 squared equals 18 squared. Subtract 13 squared from each side. So CB squared equals 155. And then find the square root of each side. CB is equal to 12.45. So our AB is equal to 2 times 12.45, which is 24.90. So there's the length of the chord. Number 6, find the measure of angle BAC. Well, here's angle BAC. It's an inscribed angle, and its intercepted arc is right here, arc BC. Well, if angle BOC is 57, that's a central angle, and it's congruent to its intercepted arc. So this is 57 degrees. And an inscribed angle is half of its intercepted arc. So the measure of angle BAC is equal to half of 57. So 28.5. Problem number 7 asks you to find x. X is the measure of this inscribed angle. It's half of its intercepted arc. So x is equal to 1/2 of 46. And half of 46 is 23. In problem number 8, we need the measure of angle BAC. Here's BAC. All right, so we've got chord AC that goes through the center. It makes it a diameter. It makes these two angles on the left side of the diameter a linear pair. So if the top angle is 66, then the angle next to it's going to be 180 minus 66, which is 114. If angle BOD is 114, then arc BC would be 114, which makes angle BAC half of 114. So the measure of angle BAC is equal to 1/2 of 114. 57 degrees. Problem number 9 asks you to find the measure of angle R, or it tells you the measure of angle R is 22. So 22 degrees. Find the measure of O, angle O. All right, so this angle R is an inscribed angle, and it intercepts this arc. All right, RN and RQ make up NQ. Well, for this central angle, or let's go back. If angle R, an inscribed angle, is 22 degrees, and its intercepted arc is 44 degrees. Inscribed angle is half of its intercepted arc. But this angle O is a central angle, and a central angle is equal to its intercepted arc. So the measure of angle O is equal to 22 times 2, or just 44 degrees. Problem number 10, given that angle DAB and DCB are right angles. So we have a right angle here and a right angle here. Measure of BDC is 47. So BDC is 47. What is the measure of arc CAD? So arc CAD starts at C. Goes around through A. And it ends at D. Well, inside this triangle on the bottom, we said yesterday that the two acute angles in a right triangle sum 90. So this angle over here, DBC, all right, DBC is equal to 90 minus 47. And 90 minus 47 is 43. And I found that angle so that I could find this arc. Because this arc is the only arc in this circle that isn't part of the measure that we need. So if we take 43 and multiply it by 2, we get 86. And the measure of arc CAD is equal to 360 minus that 86. $274. All right, and problem number 11. If the measure of angle CDB is 31, CDB 31, what is the measure of angle CAB? CAB. All right, so again, if we take angle CAB, it goes here. I'm sorry, CDB. CDB. It ends on C and B, doesn't it? It forms arc CB. If we take angle CAB, all right, CAB, angle CAB ends on C and B, and it forms arc CB. And they're both central angles, aren't they? All right. If you don't see it, we got arc CAB and we got arc CDB. They're both central angles, and both of the central angles intercept the same arc. So by rule, they're congruent to each other. So the measure of angle CAB is equal to 31 degrees. All right, does anybody have any questions on any of that? All right, so that concludes your study guide for quiz 9. I will upload it to Focus just as soon as I can